Alright, so in this example, now we're going to proceed further from just the stereographic projection and do other types of questions. The next one is finding the angle between two poles. So I've kept the stereographic projection the same as the previous question. Let's go for this first question. We have to find the angle between the pole bar 1, 1, 1 and 0, 1, 1. To find angle between any two poles on this projection through the Wolf net in the back, the goal is to get those two poles on the same great circle. So let's label those poles first. So this becomes, let's say our A bar 111 and 011 is right here. Let's call that as B. And to find angle between these two, as I said, we got to get the pole A and B on the same great circle. Now, interestingly, you'll notice that they are already on this great circle because that's how we identified the location of bar 111. So let's just count the angles. And to give you a refresher, each of this shorter length is 2 degrees and this entire length, this is 10 degrees. So we'll calculate from here 10, 20, 30, 32, 34, and about 35, between 34 and 36. So this gives us the angle between point A, pole A and B as 35 degrees. All right, and something to be careful about, you can see how my paper has started to wiggle because the hole has expanded over here. So be very careful that your sheet aligns well both on the primitive circle, which is the outside great circle, and then the north, south, east, west axis. Now the next question is to find the angle between 110 and bar 111. All right, so let's find those 2 points again. I'm gonna erase the previous markings. So 110 is right over here. Let's call that point A. Bar 111 is this one. Let's call that point B. Now you'll see that they don't appear to be initially in this on the same great circle. They're not sharing the same great circle. So this is where you have to move things around. You have to rotate this projection around to get them on the same great circle. Now one thing I'll recommend is try to keep the wolf net, the one which is sitting in the back, as it is. Don't move that, but rotate the top sheet that you on which you're solving the question. And again, when rotating, be careful of this translation that can happen because of the hole size over here. All right, so let's rotate them slowly and then try to get them on the same great circle. All right, so during the rotation, this is the A, this is the B, this is what you have to get on the same great circle. So when you slowly rotate while observing their locations, you will notice that right about here, they are on this second great circle right after this line. So let's count the angles from this point. So we have 10, 20, 30, 40, 50, 60, 70, 80, and 90. So you can see that the angle between the point A, which is 110, and point B, which is bar 111, is about 90 degrees. Now through this method you can find angle between any two poles. So let's say there is a pole, I'll just pick a random pole. Let's say there's a pole right here. All right, I'm going to call it point C. And then let's say there's a pole right here. Let's call it point D. I don't know what their current notations are, but if someone does ask you to find between these two random points or random poles, your main goal is just to get them on the same great circle. So you see how I'm rotating this sheet, and then I will come to a point where they are about on the same great circle. All right, so right about here. And let's calculate the angle. So if you start from the C, this will be 2, 4, 6. So this is 6. This will be 16. This will be 26, 36, 46, 56, 66, and about 68, 70, 72, 74. So about 74. So you see, I found the angle between these two random poles. I don't even know their rotation or their notation, but I found that the angle is 74 degrees. So this is how you can find angle between any two poles. It's just rotate your sheet to get them on the same great circle, which are these latitudes in the back. Right, and this is how you can find angle between any two poles.